Today, we're going to talk about Optimus Prime. Not really. We're going to talk about prime numbers and composite numbers. So, basically, all whole numbers can be put into two categories, except for 0 and 1. So, you have some special numbers first off. Your first special numbers. These are very special numbers because they are not prime or composite. 0 or 1. Alright, so those are some special numbers because they're the only two numbers in the entire, two whole numbers, let me rephrase that, two whole numbers in the entire world that are neither prime nor composite. So these are special numbers, 0 and 1. Special numbers, not prime nor composite. The rest of the numbers that you have ever heard, whole numbers, can be put into either category, prime or composite. All right, so today we're going to figure out how can we figure out if these numbers need to be in the category of prime or in the category of composite. So let's check it out. So what do you notice? What do you wonder? All right, so what they're trying to get you to see here is we have some arrays right there and right there. So the difference between that and these groups is that arrays have even groups. So even groups, whereas non-arrays have little odd pieces, right? So these are even groups. These are not even groups. They have odd pieces. All right. That's what they want you to see. So they want you to see arrays. All right, now they're saying, look at the following numbers. 2, 3, 4, 5, 6, 7, 8. All right. Now they want you to draw them. All right, so we're going to build as many arrays with these numbers as possible. So with 2, we could make that. And in fact, with 2, I think we could make multiple arrays. We could make an array that looked like that and an array that looked like that. So 2 by 1 or 1 by 2. I guess I should keep up with what they're doing. Maybe I should use these rectangles. All right, so with 3, we could make 1, 2, 3. Right? With 4, we could make 1, 2, 3, 4, or we could make a 2 by 2, right? Both of those equal 4. I'm going to go ahead and just to not be weird right now or confusing, let's just look at these. All right, so with 2, we were able to build a 1 by 2. With 3, we were able to build a 1 by 3. With 4, we were able to build a 1 by 4 and a 2 by 2. All right, 5, we can do a 1, 2, 3, 4, 5 square array. But if we tried to do any other ones, it would probably look a little goofy, right? Like, oops. Like the one that they're drawing right there. It would have an odd piece. I'm going to let them draw them. They're doing such a much better job of drawing them than me. So stop paying attention to my drawings and pay attention to their drawings because theirs are way more accurate. So there is 6, there's a 1 by 6, and then a 2 by 3. Oops. There's the 1 by 6 or 2 by 3. There's a 7. With the 7, there's a 1 by 7, but also, as you can see, that's not an array because there's one piece left over. And then here's one with 8. Oops. 1 by 8, and then a 2 by 4. So some of these could make multiple arrays and some of them couldn't. Like 2 only made one array, 3 made one array, and then something funky. 4 made one array, 2 arrays. 5 made one array, and then something that wasn't an array. 6 had 2 arrays. 7 only had 1, because this one was missing a piece. And then 8 had 2. So some of these could have multiple arrays, and some of them really only had 1. So let's find out why when we come back.